Hi guys, today we are continuing to talk about the quotient rule. This time we're going to be using it with expressions. So I'm going to go ahead and write out our first example, b to the third times a to the fourth all over b to the second times a to the fifth. Now just a reminder, our quotient rule is when we have the same base in both the numerator and the denominator, we are allowed to subtract the two exponents from one another. So a to the m over a to the n is equal to a to the m minus n power. So let's go ahead and treat this problem exactly like we would. If we even want to, we can draw just like a dotted line right in between our b's and our a's so that we don't get confused. And we're going to apply the quotient rule one by one. Let's work with our b's first. B to the third over b to the second. Using that quotient rule, 3 minus 2, we are going to end up with b to the first power. Now we're going to do the same thing with our a's, but if we recognize here 4 minus 5, we're going to end up with a negative exponent. Thinking back to our last lesson where we talked about this, it's going to look a little bit different. We never want to write a result with a negative exponent. It's just kind of one of those math notation rules that we follow. So to prove how this works, I'm going to write this out for you. B times b times b times a times a times a times a all over b times b times 5a's. Okay, and our job is to cross out the 1 holes there. We have 1 hole here and here. Now with our a's, 1, 2, 3, 4. We are left with this single b in the numerator and a single a in the denominator. We're going to write that as b over a. You guys will notice that whenever we have a negative exponent, it's going to end up in the denominator. We'll talk about that more moving forward. In summary, though, we used our quotient rule to determine that the result of b to the third times a to the fourth over b squared times a to the fifth is b over a. Okay, let's go ahead and do one more example. This time, we are going to have 3 w to the third times v to the fourth over w to the fourth times v. So before we even continue, there's a little bit different here because we have this coefficient of 3 sitting in front on our numerator. Now, we know that there's actually a coefficient over here in our denominator. We just, again, don't really write it out with math notation. There's an invisible 1 sitting right in front there, okay? So using our quotient of expressions, 3 divided by 1 is just 3. And then using our quotient rule, we know that w to the third over w to the fourth, we're going to end up with w to the negative first. And then the same thing here with our v's, v to the fourth over v. Remember, there's that invisible exponent right there. Whenever we don't write it, we just know that it's there. So v to the 4 minus 1 is v to the third power. But let's just prove this to ourselves by writing everything out. 3 times 3 w's and times 4 v's. All that over 4 w's and a single v. Again, remember, our job is to cross out those whole values. So we have 1, 2, 3, and then with our v's, boop, that goes away. So we are left with 3 and then 3 v's in our numerator, which if we simplify that, we can write 3 v's as v to the third. And then left over in our denominator is that single w. Same exact thing that we got over here, just written a little bit differently. Awesome job, guys. I will see you tomorrow.